Okay, so this is our last lesson. There was actually going to be one more, but I decided to cut it because it was a little bit tricky. And this also gives us 2 days to review, which will be nice. We're going to review tomorrow then and Monday and then test on Tuesday. So if you don't have all the formulas written down, here's all of our volume formulas we had so far. We are adding on one more new one. Now I wrote it like this yesterday for the prisms. I gave special formulas extra because when I first taught it, it was the same formula for a rectangular prism and a triangular prism, same formula for rectangular and triangular pyramid. The difference being that capital B stood for a specific area formula. In this case, capital B stood for the area of a rectangle because it was a rectangular prism. In this case, capital B stood for the area of a triangle. And so I'm not sure if it's going to make it easier or harder, whichever way makes sense to you. If you want to write down these particular formulas, remember how I did this? Base of T and HT, this stands for the triangle because it's a triangular prism. So you're looking at the triangle for those measurements. And this P stood for the height of the prism. Same thing here. This is the base of the triangle, height of the triangle, height of the pyramid. So whichever way, if you want to go back and watch the Edpuzzles again from those lessons, how I first taught it, you can go back over it, or here's these specific formulas. Cylinder and cone are just good to go. They're not anything more complicated. So let's add on our last one. So sphere is our last shape. So we should know what a sphere is. A sphere is a ball, right? This one is 4/3 pi r cubed. Now there's no height because it's a sphere, right? It's just one radius is the measurement that we need. And be careful that this is to the third, a cone is to the second. It's very easy to get these mixed up. So be careful with these formulas. 4/3 times 3.14 times pi times r to the third. Let's apply this formula here. Again, if you wanted to pause the video to copy these formulas, if you still need to, you could, but we're going to continue on. So it says, hey, this is a sphere. My dog is throwing a fit over here. He wants to go outside, but it's raining, so he's not going outside. So remember from yesterday that step one is to identify the shape. Well, they've identified it for us. And then we copy the formula accurately. Then we need to indicate the variables and plug in. Well, the radius is 2. So that's good to go. This is the only variable we need for a sphere. So I got to plug in 4/3 times 3.14 times, well, my r is 2 to the third. Again, be careful. We've been working with squares so far. This is to the third. So you're going to need to use your calculator for this. Again, open up Desmos if you need to. Okay, and let's see what we got. We should have gotten 33.5. It's 0.49. That rounds up to 0.5. And this is going to be, again, units. We don't know what it is exactly. Doesn't tell if it's inches or anything. This is going to be cubed. And there you go. That's it. Super simple. The only way they make it more difficult is how the next question is phrased, or the information is given to us, I should say. So this says find the volume of the sphere. So we pause, we write down the volume formula. With D equals 10. Well, this is a problem. Our formula uses R and they've given us D. Do you recall, what does that D actually stand for? R stands for radius. What does the D stand for? Diameter. So this whole thing here is 10. You are not going to plug in 10 because we need to plug in the radius, which is half of that. Diameter is the whole thing, radius is half. So if my diameter is 10, what does my radius have to be? 5, right? R equals 5, half of 10. So this is the only way they make the spheres more difficult. You have to keep an eye out for, did they give me the radius? Good, I just plug in. Did they give me the diameter though? I need to use half of it. And then it's just a matter of plugging in. We got 4/3 pi. Our R is 5, not 10. And again, sorry, be careful that you're using 3.14 for pi. So this is 4/3 times 3.14 times 5 cubed. Again, you'll probably want to use Desmos because we're dealing with that fraction there. Oops. Oh crap, did I do that correctly? Just to make sure. Yes, okay. Sorry, I'm making mistakes here. Sweet. 4/3 times 3.14 times 5 to the third. There we go. Okay, we should get, there should have been plenty of time for you to get your answer. Should get 523.33. Again, this is going to be units cubed. You guys don't need to write the units cubed. Again, you're not going to be doing that in the homework, but we just still want to get in the habit of doing it. Good habits. Okay, we have one new topic we're going to learn here now that we have all of our volume formulas. This last topic is density. So density is the ratio of mass to volume. This explains why two objects can have the exact same mass, but different volumes. So one can be smaller and one can be bigger. Remember, volume is a measure of how much space something takes up. If I cut my hands like this isn't a lot of volume. But if I'm holding a basketball, that has more volume. It takes up more space. What's going to end up happening here is, again, they will actually have different densities. So this is the formula for density. Density equals mass divided by volume. That is what it means when it says ratio. Remember that ratio is another word for fraction. So the fraction of mass over volume, that's density. So here's an example if you're like, I don't quite understand what density means. Here's an example, and you may have learned this before in health class or you've seen things about it. These fat is compared to muscle can have the same weight. Notice they both weigh 5 pounds. They're using the same scale, but the volume is different, right? This takes up more volume. Yeah, and this is less volume. Again, volume is a measurement of space. This is why people who weigh 200 pounds and are the same height even can look very different because fat takes up more space than muscle does. You can weigh the exact same amount but look leaner because you have more muscle. So, which of these would we consider to be less dense? They weigh the same, but fat has a greater volume. So that's on the bottom. So we would be dividing for fat. We'd have, again, 5 pounds in each case. But we would be dividing by a bigger number for fat. It would have a greater volume. Muscle would have a smaller volume. So if we divide by a bigger number here, that means fat is going to be less dense. And again, that's why fat is kind of squishy, whereas muscle is really hard, right? That's a measure of density. How dense something can be a measure of how thick it is, right? Again, fluff is very soft, whereas a rock is very hard. Those are actually indicators of their density. So there's one more thing. It's kind of random. It's density, but they really just throw it in here into geometry, but I have to teach it. Is we can also talk about density in terms of the population, like a population density, if you've ever heard this term before. What it refers to is, again, the population. So how many people or how many animals, we're talking about animals in an area, there are, divided by the area they live in. New York has a very high population density because it's pretty small, actually. New York is not that big, but a ton of people are stacked on top of each other and live there. So because they have a really big population and a small land area, this is a very high density. Versus Wyoming, for example, is a pretty decent sized, or let's say Alaska, actually. Alaska is a better example. Alaska is massive. If you've ever seen Alaska compared to the United States, it's like half of the United States, but no one lives there. So because their population is so small, but they have a massive land area, their density is very small. That means it's not very crowded, right? Very crowded in New York, not so crowded in Alaska. So let's go ahead and look first at density doing with shapes, and then we'll look at population density. So it says a small triangular pyramid made out of solid gold. So this is like something that Indiana Jones is trying to get. Yes, a solid gold pyramid. Has the measurements as indicated in the picture. So we got 19 here, 17 going back, that's on the ground flat, and they have 23 going up. If the triangular pyramid weighs 23,000 grams, what is the density? So again, that's my hint. We've got a lot of formulas. I'm doing density formula. Equals, let's go back and check. We should have mass over volume. So we've got mass over volume. So we have to know what we have here. We have the triangular pyramid weighs 23,000 grams. Is that mass or volume? That's mass, right? Mass is how heavy something is. So 23,000 grams is the mass. What that means is we need to know the volume in order to get the density, right? This is our end goal. We want to know what density equals. We know it's mass. Based on the measurements here, we're going to have to get the volume. So I want you to try it. This is volume of a triangular pyramid. Look back to your formulas, find the volume of that pyramid. Okay, so here's the formula. I'm going to go ahead and use the one that I expanded just so you can see that. It's 1/3 times 1/2. I know that's confusing, but this is the way it works out. Times the base of the triangle. Now what this is referring to is the base of the triangle lying flat. Yeah, the triangle it's sitting on. Times the height of the triangle it's sitting on. Times the height of the prism. Now again, the nice thing is, guys, as long as you have this part correct, as long as you did use 1/3 and then 1/2, if you mix up these numbers, you're going to get the same answer. So this is why it's super important you have the right formula, because with the prisms and the pyramids, you can actually mix up the variables, and as long as you have the right formula, you're fine. So here's my volume. This is 1/3 times 1/2 times the base of the triangle is this, 19, because we're talking again about the triangle lying flat on the ground. The height of the triangle is 17, and the height of the pyramid is 23. Notice again, I just used those three numbers. If you mix them up, you will get the same answer. So we have 1/3 times 1/2 times 19 times 17 times 23. You should have gotten a pretty big volume. 1,238. I'm going to go ahead and go 0.17 is what that would round to. It's 0.1666 repeating. That rounds to 0.17. So this is where these problems get a bit tricky. We have to keep our eyes on the prize. Our prize is density. We didn't want to know the volume. I can already predict that a lot of you guys are going to get these questions wrong because you're going to stop there and think you're done. You're like, haha, I used a formula. No, yes, we did use a formula, but not what we wanted. We need density, which is mass over volume, and that formula just gave us the volume. So let's go ahead and plug the mass in up top, 23,000 grams, and the volume on bottom, 1,238.17. This is going to give me the density. And we should get a density of 18 let's say 6, could say 5.8. I always change it my rounding, I really shouldn't. And there is our density, 18.6. Gold is pretty dense, yeah? Now again, we have to keep in mind that these units are grams and centimeters. We could do different measurements. If we did inches and pounds, we would get a different number. So we just want to keep that in mind. Okay, let's go ahead and let's try this again. Now, this one's a little bit tricky. And again, we're going to do some more practice problems with this, guys, because you have to pay very close attention to how these work out and what we're given. So it says pure water has a density of, hey, density, right away you want to pause. Let's write down the density formula because we know we're going to be using that. Let's keep reading. Pure water has a density of 62.4 pounds per feet cubed. This is just the weird units for density, but don't worry about it. But let's actually pause here. This is the density. Where should this go in the formula? In density, right? So this is going to get plugged in here. They're giving us the density. So I'm already going to go ahead and rewrite that. This is very important that we see that they have given us the density already. So let's keep reading. We have a large cone that has a radius of 5 feet and a height of 10 feet. We want to know what is the mass of the water the cone could hold. So how heavy would the water be that this cone could hold? So we are looking for what is the mass. That means in order to figure it out, we know we can only have one variable. We need to know volume before we can get mass. That's why these questions are hard, guys. We have to find something before we can find what we actually want. So let's find the volume. This is a cone, radius 5 feet and height 10 feet. Copy the formula for volume of a cone and see if you can plug in the radius and the height and get your answer. Okay, volume of a cone. I don't have a picture, but that's okay because this is pretty straightforward. Cone is 1/3 pi r squared times the height. Pi is 3.14. Radius squared, let's look up. The radius is 5 feet squared. Double check and make sure you did this correctly. And the height is 10. So plugging this into the calculator, we got 1/3 times 3.14 times 5 squared times 10. We should get 261.67 as the volume. 66 is okay as well. right, so we have to keep an eye on the prize, guys. Every time you do one of these questions, again, throughout this whole unit, there are times where we have to do a couple steps. It's not just one formula, boom, we're done. We had to use two formulas here. This is the volume. This is my prize. I want the mass, but I have the volume. So let's finish plugging this in here. We've got my density, 62.4. I want to know what that mass is, and here's my volume I calculated. So if we can recall the way to do this, to get mass by itself, let's pretend, like we did in the trig unit, that we have two fractions equal to each other. What should we do? Cross multiply. So I'm going to get the mass equals, because this is 1 times mass, which is just mass, right? And then I'm going to multiply these two things together. 62.4 times 261.67. And this is my answer. So we got 62.4 times 261.67. So we're going to have a pretty big mass here, 16,328.208. I'll write the whole thing just so we can see the whole thing. Now, I was going to do one more problem with you guys, but I think this got kind of long. So we're going to do some more practice problems together with this because I know it's hard before I let you guys go do the assignment.